A very good morning to one and all present here. I am Vidya M from Department of Mathematics, Telemaris College, Chennai, India. Today I am here to present a work titled A Study of Fuzzy Correlation Coefficient in a Soft Fuzzy Environment. This is a collaborative work with Dr. Arul Roselet Merlin and Dr. Felbin Kandi from Department of Mathematics, Telemaris College, Chennai, India. Before we dive into the details, let me outline the structure of today's presentation. First, I will present the problem description followed by the objectives, preliminaries required for the study, and the model and methodology that we have adapted here. Then we have a case study to validate the model, followed by findings and results. In many real world applications, observations are mostly qualitative in nature rather than quantitative in nature. Let us think about survey responses like strongly agree, very satisfied. These are linguistic terms that are very imprecise and uncertain. So, to capture this, fuzzy set theory introduced by L.A. Zadeh provides a mathematical framework to quantify such qualitative data that involves uncertainty. So, in this study, we have explored the concept of soft fuzzy correlation coefficient to analyze relationship between qualitative attributes that involve multiple parameters. So, what's the specific problem that we are addressing here is to quantify relationship between qualitative attributes that requires fuzzy numbers with multiple parameters. The challenge that lies here is measuring the fuzzy correlation coefficient for attributes that involve multiple parameters. We have several traditional correlation methods that work, but those work with crisp numbers but fall short when dealing with linguistic and imprecise data. Our solution is to develop a methodology using a soft fuzzy number valued information system. We apply this to measure the correlation between educational factors and social media factors in the context of academic stress among college students. So, this is the background. We aim to analyze the fuzzy correlation between attributes involving multiple parameters, for which we have considered a secondary data of 100 responses from the undergraduate students regarding academic stress. The two key attributes that we focus here are on the educational and social media factors. Both factors tend to have a significant effect on the stress level of students. Our methodology employs a soft fuzzy correlation coefficient using linear octagonal fuzzy numbers. We validate a model through a detailed case study on academic stress. Here we have the preliminary definitions. First, we have the fuzzy set. Fuzzy set is nothing but each member will be assigned a membership function in the set, followed by fuzzy number. Fuzzy number is a special type of fuzzy set on the real numbers that is normal, that has closed alpha cuts for every alpha in open 0 closed 1 and has a bounded support. Then we have the definition of a linear octagonal fuzzy number. So this has 8 parameters a1 to a8, with a1 less than or equal to a2 less than or equal to etc less than or equal to a8, and this is the membership function for the linear octagonal fuzzy number. Then we have the definition of soft fuzzy number. A soft fuzzy number is a mapping from a parameter set E to the collection of non-negative fuzzy numbers. This allows us to handle situations where data is associated with multiple parameters, which is common in real world surveys where each question, say each parameter, contribute to an overall attribute. Then we have the definition of soft fuzzy number valued measure. To aggregate the information across parameters, we have soft fuzzy number valued measure, wherein we assign weights to each parameter and we have the measure as a fuzzy number. Then we have the definition of soft fuzzy number valued information system. So we organize our data using a soft fuzzy number valued information system, which is represented as a quadruple consisting of a set of objects U, say in our case a set of students, a set of attributes A, where we can say educational factors and social media factors are the attributes that we are considered here, and it has a collection of parameters associated with each attribute. Here in this structure, we have a mapping that assigns a soft fuzzy number to each object attribute pair. This framework systematically models qualitative data with uncertainty. So, this is the mathematical representation of a soft fuzzy number valued information system. Then we move on to the problem, the case study that we have considered here. We examine academic stress among undergraduate students using the framework developed by Dr. Shantalakshmi and Dr. Alma Juliet Pamela. They have categorized academic stress into four areas: academic factors, physical indicators, social factors, and interpersonal indicators. Our study uses this secondary data from 815 undergraduate students. So we have considered a sample of 100 responses for this case study. So here we have, in our questionnaire, students rated statements on a 5 point scale from strongly disagree to strongly agree. We convert these linguistic terms into linear octagonal fuzzy numbers as shown in the given table here. We model the 100 responses as soft fuzzy number value information system, like the definition we saw previously. We calculated the academic stress in a soft fuzzy environment. The detailed output table is available via the provided link. If you need, I can project it. The core of our analysis is soft fuzzy correlation coefficient for two aspects, say J1 and J2. We compute the fuzzy correlation between their fuzzy measure sequences. Each MXI and MYI is an octagonal fuzzy number representing the value of the aspect for entity I. This extends the classical Pearson coefficient to the fuzzy domain. Here we have the alpha cuts. To compute the fuzzy correlation, we use alpha cuts for given alpha in 0, comma 1, and it is calculated using the formula projected here. Similarly for the other attribute. And here we have the alpha cut of the fuzzy correlation obtained. We applied this method to compute the fuzzy correlation between educational factors and social media factors. The data was formulated as a soft fuzzy number valued information system, and we have developed a Python program to calculate the alpha cut integrals of the fuzzy correlation in soft fuzzy environment. Here are the results. For alpha from 0 to 1, we computed the lower and upper bounds of the fuzzy correlation. So this indicates high uncertainty at low membership levels. As alpha increases, the interval narrows, reflecting more certain information at higher membership levels. Here we have our findings and results. Our key findings are: firstly, we successfully computed the SOFACI correlation coefficient using MATLAB and Python programs. Secondly, the method demonstrates flexibility and robustness in capturing uncertainty. The third the advantage that we have is the crisp correlation coefficient lies within the core of the fuzzy correlation interval. So this validates our approach to extending the crisp correlation to a fuzzy setup and in turn dealing with a soft fuzzy environment. Finally, our method is it is an effective tool to handle data with uncertainty and imprecision, wherein each attribute has multiple parameters linked to it. So, in conclusion, using fuzzy correlation in a soft fuzzy environment, this reveals a clear relationship between educational and social media factors in measuring academic stress among college students. The outcomes are uniquely insightful compared to crisp methods, especially there is a need for dealing it in a software environment. This provides a framework for analyzing data which has multiple attributes and multiple parameters linked with each attribute. These are few of my references. Thank you.